So I'll show this project which is happening in Shenoy. So this is a simple solar-based book stove, but I'll show you how the project started and how the need arose. So you are seeing these images from regular Indian rural villages. So everybody of you might have seen that they use these mud chulhas and they use wood and cow dung as the fuel source. So it has its own advantages and disadvantages. But the design, it has become obsolete because we have now solar panels and electricity. So it has its own disadvantages, as we all know. Like it is a very polluting fuel of indoor home pollution, and there is a risk of fire hazard. And but it has its own advantages also because it is quite functional. If you see their local practices and how they cook, and it can accommodate a number of vessels, large size, small size, and and the system cost almost nothing because they use their vernacular uh, constructing techniques and methods, and mud costs nothing. So, and also mud is a excellent insulation when it is used in a thick form. It provides excellent insulation. So then we went about thinking that how can electricity replace their cooking system, because right now they cook on a flame-based, fire-based system. So the need was that many of these villages, they are lie in very remote areas where there is not electricity grid, and even if there is, the supply is very erratic. And also because we have ample amount of sunshine, so why not use it? So but solar panel system usually require a battery and inverter. So because right now their cooking method, their cooking cook stove almost cost nothing. But if they install a solar cooking system, they have to invest in an expensive battery and inverter system apart from the cook stove itself and panels. So it is a very expensive system. So we thought of eliminating this battery or inverter unit and just creating a simple kit, very cheap kit, which they can just install in their houses and start cooking. So it has own its advantages and disadvantages, but we were trying to create a cheap source because uh, it has its own disadvantages because you cannot cook during night, or many a times when sunshine is not there, cloudy sky conditions, then you would not be able to cook. So then we went about thinking how to approach it. So like actually there are also, apart from once cook stoves you are seeing on your screen, there are, there are many types of solar cookers, parabolic and mirrored and box type, but they have their own disadvantages. Like they are not very convenient for local cooking methods, and you have to go out of the house to cook, and you cannot cook during night times, you cannot control the heat. So and then there are these electric hot plates. We all have seen them. So they are also different wattage. Like this is 200 watt. This is 1,500, 1,000, and 1,000. So they are basically nichrome wire, and they are either encased in ceramic coil, as you can see in the second picture, or they are insulated in terracotta or ceramic, so that the you would not get shock or current, because direct touching would make the vessel also very hot, and it can also create shock conditions. So but all these stoves are AC stoves, they are not DC stove. So also inverter and battery, what does it also converts AC current into DC current. So but now we cannot rely on these coils because they are designed such that their resistance is more suitable for alternating current. So now we have to design our system, we have to design our coil also, which can work on direct current. So then we went about technically seeing how the system would work. So theoretically, the resistance of this panel, solar panel configuration should match the resisting of heating coil. So the panel range available in the market is 40 to 400 watt, and heating coils, as you saw, 1000 to 2000 watt, and even more there are available. So our challenge was to get a consistent current supply because we are not using an inverter and battery. And user safety is also very important, because when you are not using inverter and battery, then sometimes amperage and voltage can get much higher, which is also very lethal. So as you can see, these are four formulas of calculating current and resistance. So basic calculations are done using these basic formulas, but then testing on the site, testing according to sky conditions, and there are also many variables. So the final results don't actually match the theoretical results, but the theoretical formulas are where we start. So as you can see, these current formulas. So the coil pictures you are seeing, these are the coils which we ordered, are custom-made coils. So there are 2 or 3 variables which will affect the resistance of the coil. As you can see, this last formula, resistance is equals to rho into length by cross-section area. So rho is a constant. It's the property of the element, the nichrome, and length. So the resistance is directly proportional to the length of the coil, total length, and inversely proportional to the cross-section area. So varying these two parameters, you can vary the resistance of the coil. So you can get your own resistance. Right? So then we went about doing how to approach design. So as I started with showing you mud chulhas. So they have their flame wala system. So it's directly the flames directly in contact with the vessel. So it's heat transfer by conduction, and also it's also through radiation, because fire is directly touching the vessel. So, but when we use electric hot plate, the flat plate which I shown you, so they are not very suitable for our Indian vessels, because we have rounded vessels, and also the contact area will be very less for efficient heat transfer by conduction. In the third diagram, you can see if we create a closed volume around the vessel, so vessel is touching the coil also, but a closed volume is created beneath the vessel. So what happens that the heat current flows in the insulated air gap, which is called heat transfer by convection. So the air is heated, and then the air transfers the heat to the vessel. So it is also a very efficient system if the gap is very well insulated and there are no gaps to escape the heat. So if we create a closed volume, then it is also a very efficient method of transfer of heat. So you can see all the points. So we have to take care of the shape and size of the vessels we are using, the time they usually take to cook, and easy to use, easy to move the cook stove as well. Safety, cheap, because right now their stove is costing almost nothing. So we have to make it cheap. And if it could be manufactured by local artisan resources, it would be very good. So like if we can just give them a set of panels and our own coil, and if they can create their own cook stove, that would be also a very good system. So this is the first concept which we made. So it's a basic pot, the gamla, which is available in the market. So we took this form as a starting form and put our coil inside it. So what happens? You can use it through conduction cooking. Like you can just keep the vessel above the coil, and if the vessel is big, then the vessel can sit around the rim of the pot, and the internal volume is insulated, and it's a closed volume, so convection heating can also happen, or you can just keep it directly above the coil. So then we made renders and prototypes, and like it's a quick prototype, working prototype testing rig, and we started doing testing. So the coil and stove were being developed simultaneously, so that the technology wala part is also going on the solar panel and coil thing, and our design is also simultaneously going. So then this is concept two. So this is based on, it consists of two parts. And so I'll show you the render. So as you can see, this part and this part. So you can use it directly as a conduction cooktop. And also you can use this part in two ways, like this also and this also. So what happens when you are using it in this configuration? Then this acts as a convection oven kind of thing, a normal cooktop conduction, cooking through convection if the vessel is bigger, and it can also sit on the interior rim, or you can just use it if the vessel is like the intermediate width, then it can also sit between, and then this convection cooking can happen. So again, we made renders and quick prototypes, and Rick started testing it. Then this is the design which is in its current form. So when we realized that terracotta is unlike any other industrial material, like it shrinks when it dries and you bake it, and it's not very precise. So our concept, the concept which was based majorly on the convection cooking, would not be very feasible, because there will always be gaps and inconsistencies where heat can leak. And also our initial prototypes which were being made, the mud cook stove, mud chulhas are very thick, like they are made of very thick layer of mud, like 2 to 3 inch thick. And in our terracotta layer was only like 1 inch thick. So the heat was still leaking. So right now, what we have made, we have designed a double layered terracotta stove. So this, which has a layer in between, a layer of air, so which will increase the insulation capacities more. And also we are also making multiple models to check what height would be suitable, so that convection can also happen and conduction can also happen efficiently. So these are the prototypes which we made. So this is the unit on which the coil will go. So as you can see, we have made these electric connections, and also we have put glass wool beneath to decrease the loss of heat from beneath. So that's how the coil. So right now this coil is very like crooked looking, because we gave a order of small numbers. So once you give a large number order, then coil can look much better, because they can make their own rig. So this is the pot, final pot, the last prototype. So the next prototype will be a thicker double walled pot, which will be on the same, and also a lid cover also. So these are just prototype images, stage prototypes. This was the older than which I show.
The steel module with the coil is what will be sent to people, and the pods.
So that could be a thing, because if a pot is easy to make and people can make the pot locally itself, then like we have to see it still. I'm not sure how this model will work. This can be a possibility.
What is the wattage?
The coil is 1000 watt, because without battery and inverter, we cannot like afford higher wattage coil. Basic 4-panel configuration with 1000 watt.
So students, again, very interesting, domain of how we looked at the product from a, point of view of both sustainable production and, looking at, how the product can also work much better than any of the other, other products, because of that, insulation the terracotta provides. And thanks, Mrudul.